All right, so this is 7-2. We're going to put big fat notes. The title is called Multiplying Powers with the Same Base. Please write this down. If you ever get stuck in life and I am not at home with you, hanging out, doing your homework, you could always just Google Multiplying Powers with the Same Base. On YouTube, there's tons of videos out there. This video will be out there. So you can always go back and find it. Okay. So, essential understanding is you can use a property of exponents to multiply powers with the same base. So, I'm going to underline same base. Actually, I'm circling it because that's the important part. The base has to be the same. And in case you guys didn't know, the base is the guy that is got the exponent hanging on it. So in this case, the base is 3. All I want you to do is write this part down. Write this sentence down, essential understanding, and then the 3 to the 4th times 3 to the 2. So 3 to the 4th times 3 to the 2 is 4 3s multiplied together. And 2 3s multiplied together. So at the end of the day, how many 3s are being multiplied together? 1, 2, 3, 4, 5, 6. So at the end of the day, it's 3 to the 6. So the little take home from this is...
Oh, I remember this in 8th grade.
Yes. So the take home at the end of the day is that when you have the same base, A, or 2, or 7, or P, when you're multiplying the bases together, you add the exponents, just like 3 to the 4 times 3 to the 2 is 3 to the 6. So just write down the highlighted section here. So just add the exponents. Be careful, they're going to be asking you to simplify the expression. Sometimes they'll be asking you to rewrite it in base exponent form. So really read the directions carefully to make sure you get the right answer. They may just want 3 to the 6 here and not whatever 3 times 3 times 3 times 3 times 3 times 3 is. So just be cognizant of the instructions because this is fairly easy. Okay, so I'm going to highlight what I want you to write down. Write down this here. So 12 to the 4 times 12 to the 3 equals 12 to the 4 plus 3, which is equal to 12 to the 7. Then also write down this. Although it's hard to see. Parenthesis -5, close parenthesis to the -2, parenthesis -5, close parenthesis to the 7. That's equal to -5 in parentheses to the -2 plus 7. Well, -2 plus 7 is 5, so the answer is -5 to the 5th power. You don't have to write this down, but we're going to talk it through. If you look at A, 8 to the third times 8 to the 6th. 3 plus 6 is 9. 0.5 to the negative 3 times 0.5 to the negative 8 is 0.5 to the negative 11. What if we were going to write that as, if we're going to simplify that using positive exponents, what would this look like? Positive exponent? How would I make this negative 11 positive? Yeah, 1 over 0.5 to the 11th. So that's how you make the negative exponent positive. You put it in the denominator. And then lastly, what if we have bunches of them? So we have negative 3 plus 2 is negative 1 plus 6 is 5, so you get 9 to the 5th power. All right, I just want you guys to write down A. So write down, let me highlight what I want you to write. So 4z to the 5th times 9z to the negative 12. What you do is you group the numbers together and group the letters that are the same together. And just for fun, that's why we studied the commutative and associative properties. If you were wondering why we start that in 4th grade, this is why. So 4 times 9 is 36. And then z to the 5th times z to the negative 12 is z to the 5 plus negative 12, which ends up being 36z to the negative 7. But then we got to make it into a positive exponent. So that's 36 over z to the 7. And you do the same thing whether you have numbers and 1 letter, like up here, or numbers and 2 letters. You don't combine. These rules do not apply unless you have the same base. So A and B can't be bunched together. This isn't AB to the 6th. Cannot do that. It has to be same base. One thing I do want you guys to note is that if it doesn't have an exponent on it, it's to the 1 power. So when this A happens right here, it's to the 1 power. Did you guys get a chance to write that down one more time? All right. The next really important part that I definitely want you guys to write down is scientific notation. Let me highlight what I want you to write. So I want you to write scientific notation. You can write any number as A times 10 to the B, where A is between 1 and 10. For example, 256,000 is written as 2.56 times 10 to the 5. And let me show you how that works. You take your number and take the first letter or first numeral in your number, which is 2, and you put that in front of the decimal. Everything else gets put behind the decimal. Zeros I'm not going to write. Then you put your times 10. And where do they come up with 5? Well, you go here. If my decimal point starts on this side, I go 1, 2, 3, 4, 5. I'm moving it 5 places in, and it's going to end up right in between that 2 and the 5. So because I moved it because I moved it 5 places to the left, that's where that 5 comes from. So just write down the highlighted information and this information at the bottom. Some practice problems on this to make sure we got it before I let you roll. Okay, so if we're multiplying with scientific notation, I do want you, let me show you what I want you to write down. So let's read this together. So I'm up here. At 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5 grams. Each gram of water contains about 3.34 times 10 to the 22 molecules of water. But how many molecules of water does the droplet of water shown below contain? So here's our volume. When we're coming up with a plan, we're going to do some unit analysis. This is something that your science teacher will be upset with me if I don't teach you this the right way. So I start out with molecules of water. It is in cubic meters. Boop. See that? Cubic meters. So it's in cubic meters. How many grams per cubic meter are there? And then how many molecules per gram are there? That's unit analysis. So that way cubic meters cancels out cubic meters, grams cancels out grams, and I'm just left with molecules. All right, so what I want you guys to write down this here. So 1.31 times 10 to the negative 7 times 9.98 times 10 to the 5 times 3.34 times 10 to the 22. Because I want you guys to see how you group the numbers together. And the 10 to this together. So you guys can just use a calculator. That's my picture of a calculator. You're welcome. To figure this one out. I know, it's awesome. You're jealous that you can't draw as good as I can.
Pretty jealous, actually.
I know. So when you use a calculator, you just multiply these little numbers together and you get 37.7. And then what you do with the tens, because we have the same base, you can just add in the exponent. So negative 7 plus 5 plus 22, and that's 10 to the 20. We have a little problem though. You're only allowed to have one number in front of your decimal point when you're in scientific notation. So scientific notation, we've got to move this decimal place one more to the left. So when we move it one more to the left, it increases our exponent by 1. So at the end of the day, the answer is 3.77 times 10 to the 21. So fractional exponents are called rational exponents. And then I want you to write this down. 9 to the 1/2 power is 3, since 3 times 3 is 9. And then write this down. In general, a to the 1/m equals b means that b multiplied as a factor m times equals a.
What?
Just right. You're just writing it down. We're just taking notes. We'll do example problems in a second. All right, for example, 16 to the 1/2. So what number multiplied by itself twice will give you 16? Answer is 4. It's exactly the same as square root. So square root is the same as 1/2 power. So like 81 to the 1/2 power is 9, because it's the same as square root of 81. Now, here's what we think about here. Switching up on you a little bit. What about to the 1/4 power? What times itself 4 times will give you 81?
No, 3.
Well, we know 9 times 9 is 81, right? And we can say 3 times 3 is 9. So 81 to the 1/4 power is like the 4th root of 81.
Can you go back one, please?
So to wrap this up for your notes, to multiply powers with the same base, add the exponents. You got that. So you guys already have that written down, but I want you to write down the examples here, especially when you have a fraction.